They've given us a line, area under that line, and they want us to find the blue area with an integral. So how are we going to do it? Well, we're going to go from 1 to 3. That's the A and the B, the 1 to 3. The integral symbol means sum. It's a big S for the word sum. Sum up, add up the area. And as we do, it's going to be f of x dx. So what is f of x? Well, this is the function up here, f of x. This right here, that's the line we're talking about that the curve, the blue shading is under. So what's the equation of that line? Y equals mx plus b, or if you want, f of x, whatever, same thing, equals mx plus b. So we got to find the equation of that line. What is it? Well, remember, b is the y-intercept. So the y-intercept, clearly, it looks like you can tell that 5 is kind of off the screen, but it's hitting at 5. Okay, and then the m is the slope. This is y. Slope is rise over run. So the question is, what is the rise and run? Well, what you want to do is you want to go between two clear points. So like say this point and that point. Why am I picking those two? Well, those clearly hit right on grid lines. Never mind the fact that I drew the green line a little bit off. It really, you can see the black one's still there. It hits right on that point and right on that point. Whereas I don't know where that one hits exactly. I don't know that one, don't know that one. But I know this one's right on the grid line. This one's right on the grid line. So use that. And so what is it? It goes down one, that's the rise. And then the run goes over 1, 2, 3, 4, plus 4 is the run. So rise over run, down 1 over 4, x plus 5. So there's the equation. They did it right there. They made it at negative 0.25 as a decimal, but same thing. Finally, we want to figure out the area. So how do we calculate all that blue area? Well, that's the integral. We're going to do exactly this integral. We're going to do the integral from 1 to 3 of the function f of x. Here's the function right here. So minus 0.25x plus 5, or you could have made it minus the fourth, whatever, same thing, dx. That'll give you the area. That's what an integral means. It means sum up all the area under this function between 1 and 3. So what do I do? How do I do it? What is this? This is antiderivative. That was the big discovery of calculus by Newton and Leibniz in the 1600s. Antiderivative. So this is 1 power. So to do the antiderivative, you're going to add 1 to the power. It'll become x squared. In fact, here, let me just do it over here. Well, I can do it right here. X squared. I'll take that minus 0.25 and it'll divide it by the 2, right? So you add 1 to the power and divide by that number, plus, and this one's going to be 5x. That's the anti of this one. Why? Because the derivative of 5x goes back to 5. Okay, and now we're going to evaluate that between 1 and 3. So I'll bring it up here. So that means we're going to take that whole function, minus 0.25 over 2, 3 squared. I'm going to plug in the 3 there and there. That's 5 times 3. I'll make these brackets just so it's more clear. Okay, and then minus, and then another bracket. And now we're going to plug in the 1 there and there. So it'll be minus 2.5 over 2, 1 squared plus 5 times 1. There we go. So we got to go to Desmos and type all that in. When you do, you get 9. There's the answer. That's the area under. Now, we could have found it by geometry, like adding up squares and stuff, but integral automatically gives you that area. And so there we go.